Welcome, my dear learners, to today's episode on this very channel. From today up to the next few days ahead of us, we'll be looking at the topic matrices. Matrices is the plural form of the word matrix. So what is a matrix? A matrix is a rectangular array of numbers encased in parentheses. In other words, it is a rectangular arrangement of numbers enclosed in parentheses. Now, let's look at the explanation to this definition. We are talking about a rectangular arrangement of numbers. So the letters A, B, and C, and then D represent these numbers that we are talking about. And we are going to arrange these numbers to look like the shape of a rectangle. So we have these numbers arranged to look like what? A rectangle. And then enclosed in what? Parentheses. So we are going to enclose these numbers in parentheses. So I always like using the macro brackets. You can also use this bracket, it is accepted. Good. Once this is done, we can say that these numbers have been written in a matrix form because we are talking about what? A rectangular array of numbers enclosed in parentheses. We can also look at this example. So this is also a classical example of numbers written in a matrix form. We can also look at this particular example. This is also a classical example of numbers being written in a matrix form. So all these examples and many more are examples of numbers being written in a matrix form. Matrices are denoted with capital letters. So if you want to call this matrix matrix A, then we are going to represent it with a capital letters. So letter A. Matrices are denoted with capital letters. So let's call this matrix matrix B. The same thing applies to this. The members or numbers within the matrices are called entries or elements. The members or numbers within the matrices are called what? Entries. The horizontal arrangement of the numbers in matrix are referred to as what? The rows. The horizontal arrangement of the numbers in matrices are referred to as what? The rows. And then the vertical arrangement of the numbers in matrices are referred to as the columns. Kindly take note of this because this plays a key role in matrices. A matrix can be described by using the dimension of the matrix. And when we talk about dimensions, we are referring to the number of rows and then the number of columns. So looking at matrix A, how many rows do we have? How many columns do we have? So when we are talking about the rows, we are having one row, two rows. So matrix A is having two rows. How many columns do we have? Matrix A is having first column, second column. So matrix A is having two columns. So the dimensions of matrix A are two rows and then two columns. The expression 2 by 2 is called the order of the matrix. So the expression 2 by 2 is called what? The order of the matrix. But when we talk about the dimension, we are referring to the number of rows and then the number of columns. Now let's look at matrix B. What is the dimension of matrix B? We are looking at what? The number of rows and then the number of columns. So matrix B is having how many rows? 1 and then 2. So we have 2 rows And then how many columns? We only have one column. So we have one column. So the order of matrix B is a 2 by 1 matrix. But the dimensions are 2 rows and then 1 column. What is the dimension for matrix C? Then we are going to look at the number of rows and then the number of columns. So how many rows do we have? We are having 1 row, so we have 1 row. How many columns do we have? 1, 2, so we have 2 columns. I believe you are following and you are getting the concept. Let's look at types of matrix. The first one that we are looking at is the row matrix. What is a row matrix? A row matrix is a matrix which contains exactly one row, or it's a matrix which contains only one row. So all these examples are classical examples of a row matrix. Matrix A is a row matrix because it contains only one row. Matrix B is also a row matrix because it contains only one row. And the same thing applies to matrix C. The number of columns in a row matrix can be as many as possible. So looking at matrix A, we have how many columns? We have 2 columns. Matrix B, we have 3 columns. Matrix C, we have 4 columns. So the number of columns in a row matrix can be as many as possible. But a row matrix have only one row. So let's look at the order of these matrices. So the order of matrix B is going to be a 1 by 3 matrix because it has 1 row and then 3 columns. What about matrix C? We are going to have 1 by what? 4 because we have 1 row and then 4 columns. And then matrix A, we are going to have 1 by 2. So the orders are 1 by 3, 1 by 4, and then 1 by 2. So you realize that in all, we are having the rows to be 1, 1, and 1. But the columns, the number of columns keeps on changing. So in general, we can say that the order of a row matrix is given as 1 by n, where n is the number of rows of the matrix. Now let's look at the next matrix, which is the column matrix. Now when we talk about a column matrix, it is a matrix which contains only one column. So you can see that matrix A contains only one column, matrix B contains only one column, and matrix C also contains one column. Let's look at the order of matrix A. How many rows do we have and how many columns do we have? We have 1 row, 2 rows. So we have 2 rows. How many columns? We only have 1 column. Let's look at the order of matrix C. We have how many rows? 1, 2, 3. So we have 3 rows. And how many columns? 1 column. Let's look at matrix B. We have how many rows? We have 2 rows and 1 column. So from these orders, we can observe that the number of columns in all of these examples, they are 1, 1, and 1. But the number of rows keeps on changing. We have 2, 3, 2, 4, and so on. So in general, we can say that the order of a column matrix is given as n by 1, where n is the number of rows. And the rows in a column matrix can be as many as possible. Let's look at the next type of matrix. So we have a squared matrix. A matrix in which the number of rows is equal to the number of columns is said to be a squared matrix. So let's look at each of these matrices to see if the number of rows is equal to the number of columns. Let's start with B. So we are going to look for the dimensions of matrix B, meaning we are going to look for the number of rows and then the number of columns. How many rows do we have? we have the first row, the second row, and then the third row. So we have how many rows? 3 rows. How many columns do we have? We have the first, the second, and then the third. So we have how many columns? We have 3 columns. And we can see that the number of rows is equal to the number of columns. So we can say that matrix B is a squared matrix. Let's look at matrix C. How many rows do we have? We have first, second, third, and then 4. So it means we have 4 rows. How many columns do we have? We have 1, 2, 3, and then 4. We are also having 4 columns. And the number of rows is equal to the number of columns. So we can therefore say that matrix C is a squared matrix. Matrix A is also a squared matrix because the number of rows is equal to the number of columns. So you can see that this matrix is a 3 by 3 matrix, matrix C is a 4 by 4 matrix, and matrix A is a 2 by 2 matrix. And all of these are examples of a squared matrix. Let's look at zero matrix. Zero matrix. Now when we talk about zero matrix, we are referring to a matrix in which all the entries or elements are 0. So we can observe that matrix A is having 0 entries, matrix B is also having 0 entries. The same thing applies to matrix C. So you can see that all these matrices are 0 matrices. We also have some other types of matrices that you can look at it at your leisure time. And these types are the equal matrix, the unit matrix, the diagonal matrix. This brings us to the end of today's lesson. See you tomorrow. Bye bye.